If we add more capacitance, it moves us counterclockwise along a circle of constant resistance. If we add shunt inductance, it moves us counterclockwise along a circle of If we add shunt capacitance, it moves us clockwise along a circle of constant conductance. First, we normalize the z equals 25 plus j50 by dividing by a number like 50. That gives us z sub n equals 0.5 plus j 1.0. Plot that point, then calculate the shunt value to get to R equals 1.0 circle, which is 35 picofarads. Then calculate the series value to get to R equals 1.0, which is 94 picofarads. Remember, calculate impedance and SWR along a transmission line. The circle is made up of resistance circles and reactance arcs. The large outside circle is the reactance axis. The straight x-axis is the resistance axis. SWR circles are circles of constant SWR. The wavelength scales are fractions of the transmission line wavelength. For transmission lines, remember rule number 1. If any transmission line is an integer multiple, that is like 1, 2, 3, of 1/2 wavelength, the impedance at one end will be the same as at the other. If an antenna is at 50 ohms and it is fed with 75 ohm coax, if the coax is at a 1/4 wavelength, the impedance will be 50 ohms. Rule number 2. At odd multiples of 1/4 wavelengths, such as 1/4, 3/4, 1 1/4, etc., the impedance at one end is inverted at the other end. If one end of a 1/4 wavelength of coax is shorted, the other shows open. These charts show the behavior of open and short-circuited transmission lines. You can see the cyclic nature of the impedances in the line. To match two different impedances, such as the transmission line and the load, a 1/4 wavelength section of transmission line with the value halfway between the two values will do the job. For instance, to match a 100 ohm antenna to a 50 ohm coax, you need a 1/4 wavelength section of 75 ohm or RG59 coax. Antenna analyzers make quick work of taking SWR measurements. Some will take measurements from 160 meters through 440 megahertz. Some are battery powered, and some can be used even up on a tower. Personal computers have made it possible to design and analyze antennas by mathematical modeling. These programs compute antenna gain, beam width, patterns, feed point impedance, and SWR versus frequency. What is an effective way of matching a feed line to a VHF or UHF antenna when the impedances of both the antenna and the feed line are unknown? A. Use a 50 ohm 1-to-1 balun between the antenna and the feed line. B. Use the universal stub matching technique. C. Connect a series resonant LC network across the antenna feed terminals. Or D. Connect a parallel resonant LC network across the antenna feed terminals. The answer is B. Use the universal stub matching technique. What is the velocity factor of a transmission line? A. The ratio of the characteristic impedance of the line to the terminating impedance. B. The index of shielding for coaxial cable. C, the velocity of the wave in the transmission line multiplied by the velocity of light in a vacuum. Or D, the velocity of the wave in the transmission line divided by the velocity of light in a vacuum. The answer is D, the velocity of the wave in the transmission line divided by the velocity of light in a vacuum. What do the arcs on a Smith chart represent? A, frequency. B, SWR. C, points of constant resistance. Or D, points of constant reactance. Answer D, points of constant reactance. What impedance does a quarter wavelength transmission line present to a generator when the line is shorted at the far end? A, very high impedance. B, very low impedance. C, the same as the characteristic impedance of the transmission line. Or D, the same as the generator output impedance. Answer A, very high impedance. How should a portable antenna analyzer be connected when measuring antenna resonance and feed point impedance? A, loosely couple the analyzer near the antenna base. B, connect the analyzer via a high impedance transformer to the antenna. C, connect the antenna and the dummy load to the analyzer. Or D, connect the antenna feed line directly to the analyzer's connector. The answer is D, connect the antenna feed line directly to the analyzer's connector. What is a disadvantage of decreasing the number of wire segments in an antenna model below the guideline of 10 segments per half wavelength? A, ground conductivity will not be accurately modeled. B, the resulting design will favor radiation of harmonic energy. C, the computed feed line impedance may be incorrect. Or D, the antenna may become mechanically unstable. The answer is C, the computed feed point impedance may be incorrect. Our next subject is propagation. We begin with HF propagation. Ground wave propagation results from the lower part of the wave losing energy because of currents induced into the ground. This slows the lower part of the wave, causing the entire wave to tilt forward slightly, following the curvature of the Earth. Signals that travel into the ionosphere can be refracted, that is, bent, by ionized gas in the ionosphere's E and F layers, returning to the Earth some distance away. There is long path propagation and there is short path propagation. Most of the time we prefer short path propagation. Look for gray line propagation around sunset and sunrise. Gray line propagation can work for short and long path propagation. Here is another illustration of the gray line. What type of polarization is best for ground wave propagation? A, vertical. B, horizontal. C, circular. Or D, elliptical. The answer is A, vertical.